Welcome everybody. As we used to do, pause the video and read the question carefully. The question says, the enthalpy change of formation of delta HF for both PCl3 and PCl5 are exothermic, which means the delta H's are negative for both. The question says PCl3 reacts with the chlorine, as we can see in here. Since we were given the delta H values and the delta HR is given to me, we can remember Hess's cycle of formation. And it says that you have reactants, here we have a products, and down below we have to write the elements. And since we have only two elements at this point, we have phosphorus plus 5 chlorine. Chlorine elements appears in nature as diatom. In order to make balancing, we have to say 5/2. And for sure in this Hess cycle, we have to draw the arrows to be at this point like this. And if we start willing to calculate the delta H at this point, we have to say like this value. And then we have, since we are moving like this, we have to reflect the delta H. That's why it becomes delta HF. But the delta H here is for a PCl3 because the delta HF value for a chlorine, since its element is equal to 0 based on the rule. Alright, and for PCl5, since the arrows are in the same direction, we don't need to reflect the sign of delta H, and that's why it remains as it is. In other words, the delta H is equal to, of the reaction, is equal to PCl5, the delta H of PCl5 minus the delta HF of PCl3. And then we have a negative answer at this point. But we have to look at the equation at this point. The delta HF of PCl5 and PCl3 are exothermic, which means that both are negative. And since we have negative answer, then if we say like this is negative minus another negative equals a negative answer. If we look at the exothermic reaction of PCl3, since it's already subtracted, at this point it becomes positive. In order to have a negative answer, you should have a very great magnitude of negative PCl5. I just want to clarify this point here more. PCl3 equals a negative answer. Since both are exothermic, then this one here is negative delta HF, and this one here is negative delta HF, and the overall is negative. In order to keep this sign here as a negative form, the value of delta H here should be more negative. Okay, so let's go and see the answers. A says delta H of reaction is less negative than the delta H of PCl5. Basically, this one here is true because I need the PCl5 to be the more negative one here in order to have a negative answer. It says that the Cl2 bond energy is needed. No, I didn't need it. A is not true. B says the delta H reaction is more negative. No, it's not more negative. And C says the delta H reaction is less negative than PCl5. Yes, I need PCl5 to be more negative in order to have a negative answer. And the second sentence says the Cl2 bond energy is not needed in calculating, which is true for sure because I didn't need it since the delta H of element is equal to 0. And that's why the answer is C.